Alright guys, part 3. Again, those of you who had headaches on this homework, thank you for having headaches because you really tried on this homework, okay? Those of you who did not have headaches, no worries. But you got to know this for the test. This is just a completion grade for you to see the level that you're going to be tested for the test. If you don't have the correct answers, no worries. It is a completion grade to turn in. Please make sure that you've completed it. I wanted to look at 4A and B. Again, you can find more of these on that website that I showed you. A lot of video examples, okay? And he's pretty thorough as far as his explanations. Here we go. The most important thing about this integral that's been given is to identify that 1 is where it's at. Because if x was 1, what is r of 1? 0. Why? There's no vertical or horizontal over an interval displacement. 1 to 1, this is 0. We good? So right now, you don't see it, but on the graph of r, there is a point that has an x of 1 and a y of 0. Okay, so I could draw over here to the right. This is r of x. And at 1, the y value is 0. Okay? Good? Alright, so now let's look at so r of 1, that was the easy part. Now let's find all the intervals when r of x is positive or equal to 0. Okay? Here we go. I can look at this many different ways. One of the easiest ways that I see is to derive second fundamental theorem and see r prime is equivalent to what? F of x, right? Because remember, you plug in the bound and multiply by the derivative. We're good? So this can be seen as f of x and f of t. It is a given f of t, but when I derive it, I can see it as f of x. Same graph. Okay? So if I want to see whenever it's positive, then I want to see when is this above the y-axis. Go with me? So here we go. If I look at the next 0 that's important, which is 6, and I calculate it from 1 to 6 of the graph, the original graph, I can see that this area is all positive. So that's like if you were on the 0 floor and you endured a positive displacement, you would go up, which would be positive or above the x-axis. You with me? Another way that you could see that, the way that I would see this, would be if r prime of x is equal to f of x, and I know that when r prime is positive, that means r of x is increasing. You see what I'm doing? Then all I have to do is ask myself, when is f of x positive? Well, it's positive when it's above the x-axis, all right here. So from 1 to 6, it is increasing a lot. The entire time, it's increasing all the way from 1 to 6. It increases the most here, and then it slowly increases like that to 6. How about from 6 to 7? It decreases because the f of x is negative, but it's only going to decrease a little bit. So we could say it decreases. And then how about from 7 to 8? It increases a lot because this is positive. means r prime is positive, means r of x is increasing again. Y'all see that? Now look. At 1, 0 was the point of interest because everywhere before had a positive displacement. Means that it had to come from way down here to increase to get to 1, 0. Which all of this is not above or equal to the x-axis. So the answer for this would be from 1 to 8.
The way I thought of that was I did the second half, after 1 the same, but then before 1 I looked at the integral, r of x, and since it's before 1 it would be negative.
Yep. You could look at it like that too. Or you could even say to yourself, r prime was still positive because it was above, which f of x is a positive, which means it was increasing that whole time to get there. Yeah.
So it's not negative 3 to 1 because
it's not negative 3
because of the bounce. It starts.
It starts.
It would be negative because you would
Well, do you know why we chose 1? It all revolved around choosing 1 right here.
Because it starts at 1.
Because you can at least identify that this value will be 0. Now look, don't look at this domain. I really don't want you to look at the domain and be like, oh, the domain is just going to be from that x value to that x value. The domain of f of x is, but if I'm saying you know what I mean, different domains could be the y values, or the domain could have been the area underneath the curve, depending on how you're defining it. R of x as the integral, or of r of x as the position graph.
But since negative 3 to 1 is still positive, that means it'd be increasing, but it'd be below the axis.
Yes. Nice.